Hello everyone, in this video I'm going to show how to perform agglomerative clustering using R. First we are going to upload the data. To do that we first need to name our data frame and let's call it my data. My data is equal to read.csv and in quotation mark it's cities.csv. So before you use this function, please do not forget to set your working directory. And here in this case, my working directory is already being chosen. And then we do Control Enter here. And now you can see my data file. Let's first try to understand the data set. And this data set contains data relating to the crime rate. In the second column, crimes per 100,000 residents, the poverty rate in percentages, and the median income in $1,000 for 41 cities in the United States. And next we are going to install the required packages to do agglomerative clustering. And for that reason we will use install packages command. Install packages and the packages cluster. And then Control Enter. And next, in order to activate this package, we use library cluster. And then Control Enter. So the package is ready to be used. Next, we need to standardize the data and we exclude the city variable from the analysis and standardize the crime, poverty and income variables and store their standardized values in a data frame called myData1. In order to standardize the data, we use scale function. So here let's type it standardize the data and new data frame myData1 is equal to scale and in the parentheses my data and all rows, but we are going to get the columns 2 to 4 because we want to exclude the cities. Control Enter. When you look at myData1, you see it has only crime, poverty and income. So if you don't need to do standardization, just need to type the command myData1 is equal to my data and you are going to select all rows again 2 to 4. But since we need to standardize, I don't need this command. I'm deleting this part. So the next thing is we need to choose a distance function. Let's write here distance. And we use this function to determine the similarity among observations and store the distance values in a new variable called d. So we are going to use a new variable d. So we are going to type next dist. This is the function. And the data frame we use is myData1. And for methods, we need to choose a method to specify the distance calculation. Options for distance calculation include Euclidean, Manhattan, and for binary options it's called binary and it uses Jacquard's coefficient, maximum and Minkowski. So maximum and Minkowski are not going to be covered in your textbook. And we specify Euclidean to use the Euclidean distance for this exercise. Therefore, I'm going to type here Euclidean. And then Control Enter. Now the value d is created under environments pane. And next we need to use Agnes function to do agglomerative clustering. And for this we are going to first define a variable which we call it a results. This is going to save the results here. And then we type Agnes. And in the parentheses we need to first choose d. That refers our distance. And then next we type this is equal to true. The reason we type true here is because we know that the d, the variable that we created, contains a distance matrix instead of the original variables. Therefore, we set this to true. And next we need to choose a method. In this case, there are several options for clustering methods. And these are single represents single linkage, complete represents complete linkage, average, word represents words method, weighted and flexible. And we are going to specify here word. And then again, Control Enter. So as you see here, we have a results under environments pane. And in order to visualize a results under console, you type here a results and then Control Enter. And now you can see here the results on the console pane. when you look at the results, please make sure that the coefficient value, agglomerative coefficient, is greater than 0.75. Because if it's greater than 0.75, it is indicating that there is a good and natural clustering structure in your data. So in this case, the clustering coefficient here you see on the screen is 0.942097, which suggests that a good and natural clustering exists in the data. And next we are going to use plot function to produce the dendogram as well as banner plot. And here let's type here dendogram, and we use plot function in the parentheses a results, close the parentheses, and then click on Control Enter. And as you see here, you are prompted to press Enter or Return to display the plots. And come here and click, and then press one time Enter. You'll see the banner plot. And when you check the banner plot under Plots pane, you realize that banner plot represents observations, and each empty gap between the red bars represents potential clusters. So here you see there is an empty bar, so that represents a one cluster here, and there is another empty bar here that represents another cluster. So as with the dendogram, we can cut the banner to obtain a desired number of clusters. In this example, just look at here, if you cut it around 7, you will have 3 clusters, 1, 2, and the third one. And if you come here, click, and then press Enter second time, you will see the dendogram. And by looking at the dendogram, you realize that 3 clusters is ideal for this data, 1, 2, and 3. So based on the inspection of the banner plot and the dendogram, we can determine the number of clusters, and we will use cut tree function to create 3 distinct clusters. So here we are going to now create clusters, and we need to name the variable we create for clusters. A clusters is equal to cut tree function, and in the parentheses a results are where we save our results, and k is equal to 3, and then Control Enter. And A clusters are created under values. Now the next is we want to append the cluster membership to the original data frame, which our original data frame is my data, and we are going to use data.frame function. We then use the view function to inspect updated my data frame. So now we are going to append the clusters. And in order to do that, we use data frame function. My data is equal to data.frame in the parentheses my data, comma, A clusters, and then Control Enter. And in order to see the data set, we can use view my data and Control Enter. As you see, the clusters are now as a separate column in our data sets. Now next we are going to use summary function to obtain summary statistics for the 3 clusters. So let's say summarize the results, and we will use summary first, summary, and the parentheses subset my data, and with subset A clusters equals 1. So this is going to give us the summary statistics of cluster 1, and we can copy this here and type here instead of 1, 2, and here 3. Let's see what are the summary statistics for cluster 1. You can find the summary statistics now on the screen for cluster 1, and for the second cluster you can do the same, Control Enter, and for the third one, Control Enter. To find out the number of observations in each cluster, we use the as.factor function to convert a cluster to categorical data and then use the summary function to find out the number of observations in each cluster. So to find the number of observations, so number of observations in the cluster, number of observations in each cluster, what we are going to do is summary function as that factor. We need to convert this into categorical data and A clusters, and then control enter. You see the number of observations in cluster 1 is 11. Look at the console pane. For cluster 2 it's 21, and for cluster 3 it's 9. So you can summarize everything into a nice table. We can compare the average values of crime, poverty, income for 3 clusters, cluster 1, cluster 2, and cluster 3, based on the summary statistics. And average crime rate is 235.9 for cluster 1. Cluster 1 seems like it is a group of 11 cities with the lowest crime rate. Compare this 235 with 544 and with 1160. And the lowest poverty rate, again you can compare mean value 5.5 to 12.28 and 21.46. And highest median income. Let's look at the median income. For median income, cluster 1 is 59.73, cluster 2 45.27, and cluster 3 35.26. Then therefore you can title your clusters as lowest crime, safest cities, and you can put the second cluster to the second rank, and the third one represents the cities with highest crime and lowest income.